everyone, and good afternoon. It is September the 17th, 2025, and my name is Sal Cosentino. Um, for everybody following me, I'm a mentor, trainer, and aspiring cloud architect. All right, and the reason for this video is to kind of go back into some questions that again people had and we're going to be using again as our control plane as our background. We're going to be using VMware Workstation Pro. We in a virtual environment, right? So physically, uh, we have to understand some of the concepts here when we're using a laptop versus when we're using physical hardware devices, right? And how the networking corresponds differently, and how the basics of networking is structured, and how essentially the art and science of connecting devices so that they can communicate and share data, right? So, laptop has a hard drive, server has a hard drive, or many hard drives, right? Laptop has Desktop has two drives, right? Or whatever, et cetera, right? We need to understand that essentially there's the art of science here, and this is how it works, right? So um, we can't reinvent the wheel here. There's no your network is your network and my network is my network. We're renting networks here. We can create, you know, our own LAN environment in our home and office, and we can create larger areas like internet for our WAN, and we can cover cities or campuses with our MAN, and we can connect very small, uh, like a Bluetooth connection with PAN. And the art of science is connecting these devices so that they can communicate and share data, right? So when I create these videos, I'm sharing data between OneDrive, my laptop, to another drive, which is sits on top of our operating system, right? So our operating system has a hypervisor, right? Type 2 software. And then within those, we build our virtual machines, and those virtual machines can communicate with each other, right? So again, those virtual machines can communicate with each other, and they're communicating with our LAN, right? Or Ethernet. These virtual machines also have LANs, right? So they also have network cards. And again, this is what helps connect computers, right? These groups of devices, right? So we have groups of devices such as computers, right? Servers, right? Phones, printers, and etc. Right? Look here, right? And it's a little bit bigger here. Okay, sorry guys. I just want to get this as big as possible for you all to understand what. Let's move this out of the way, right? And let's make this a little bit bigger. right? And let's grab our common ones here. And so we talk about groups of devices, and this is what a network is. What is a network, right? And this is a question that a lot of people ask: is, well, what is it? It's the art of science. Yeah, we get it. That helps us connect these devices so that we can communicate and share data, right? But you have to understand what is a network and what it does, right? And not only are we connecting, not only our network is a group, right? Right? But it also connects when connected. It shares resources like files, printers, and gives internet access, right? Right. So that's important. Oh, geez, right. Um, my box here. So you guys kind of get this, the art of science, right? It connects our devices so that we can communicate and share data. And again, first question is what is a network? And a lot of people get confused. Those, what is a network? It's not networking per se, like networking people. It's networking in IT and information technology, right? So you have to understand that this is information technology, right? So it's the technology of information being built, being designed, being given to the people in this world, right? Right. And when we look at what is information technology or IT, right? We talk about the use of those computers and networks, right? So it's a subcategory of those computers. It's a subcategory of hardware, right? Like your computers and servers. It's a component like software, right? Networks as what we're talking about, right? So it could be wired or wireless, right? So this network is a group of computers, right? That's what builds that network together. And these connections either wireless or wireless, right? So they can be wireless or wireless, right? And again, there's also data and then there's people, right? So these are the different components that I want to bring up to for you because um, you have to understand that components are hardware, right? Like your physical devices, software, and this is what information technology is: networks, data, and people. There are different key areas. There's importances of IT. There's different examples in action, right? Like there's different things that we can define information technology. Knowing what that is, right? And again, when we talk about IT, it's more of a broader term that refers to use, right? The use of information. And a lot of people use IT, it's just an acronym. And I hate using acronyms. I love telling people what that means. And again, information technology, right? And that's what that is, right? Uh, People design it, people build it, right? People process, transmit, manage information, right? And when we talk about information technology, it's a broad term, which means computers, right? Compute networks, right? And similar to that, those core components, right? And other technologies. sure I get that right for you guys. And software, right? And other technologies. And these other technologies are used to store, process, transmit, and also manage information. Now, IT is also, information technology is also the backbone that allows businesses, governments, and individuals like ourselves to handle information, well, digital information efficiently, right? So understand that, we we can have applications of computer, right, in IT and telecommunication equipment to store, retrieve, transmit, and manipulate data, which is often the context of a business or another process, or just an enterprise environment, right? So, you know, um, the application, IT is the application of computers and telecommunication equipment to store, like I said, retrieve, transmit, and manipulate data. And we talk about this in the context of business, right? This is more for business and enterprises, right? Enterprises. We have our core components of IT, right? We talk about that. Enterprises, right? We have our 5 components listed here, and we have to understand that, we also need to understand the key areas of those the IT, information technology. We have to understand its importance. We have to understand also its examples of IT in action, right? So, for example, you have a banking app that allows online transactions. That's IT. Cloud platforms like Google Drive or Microsoft 365. That's also IT in action, right? Enterprise systems like your Oracle for Business Management or SAP, right? Then we also have online learning platforms and tools that we use for collaboration and cybersecurity, where that measures protecting sensitive company data that involves IT in action, right? So, in short, it's all about using technology to manage that information efficiently, securely, and effectively, right? So, these are some great words, right? We can ensure that again, it's about using technology to manage this information efficiently, securely, and effectively. Effectively. This is important, right? We're not going to get into the computer science of it, but going back to our diagram, uh, right? We talk about, what networking is and how the networking, groups are. It's a group of our computers, our servers, our phones, our printers, and etc. Right? There's different our devices that we can use, and when connected, we can share those together. We can share resources like files, printers, right? Access and give internet access to people, right? Um, we can also talk about the different types of networks that are available in life and science. And, you know, we have our LAN, right, which is our local area network. And in short, it covers a small area like your home or office. Then you have your WAN, which is your wide area, right? And I typically, right? And then when, oh, back here, right? So we have our LAN, which is our local area network. And I'm not going to get into the exponential part of it, but again, it's your local area network. And to quickly tell you what that is it just covers a small area like your home. So it covers your area, your home, or just your home office, or your office in general, right? Then we also have our WAN area, which is our wide area network. Right. Then we have our MAN, which is our metropolitan. And then we have our, let's just remove the spaces. Right. And then we have our PAN, which is what I've already discussed with you guys a few minutes back. And that is our personal area. Very small, right? And our personal area is like our Bluetooth connections, right? So that's very personal to us. So art of science, right? Connecting with each other. We need to connect and share data between two different devices. Our laptops and desktops have networks and Ethernet cards and NIC cards and network interface cards that are built in and within our software, within our type 2 software, which is going to be our Workstation Pro, right? So this is going to be our Workstation Pro 17, which is what we saw in a lot of our videos here today. And we built machines within my laptop, and we have our network, and we have our virtual machines that are going to um, give us that communication over the network uh, to talk to each other, right? And again, you know, our hardware is our networking, right? So we have our router that gives us our connection, and this will give us our internet, right? So using that, we can go and access the internet, right? As much as we want and as freely as we want, right? And again, in order to help connect computers, right, we need those specific devices. And again, we have devices like routers. We have devices like switches, hubs, access points, and modems, right? So these are our physical devices that are accountable for those specific reasons. And let me see if I can zoom in. Okay. So those are the devices that help us communicate together. And right, we're going to make sure that these devices allow us to communicate to the internet, right? Routers, obviously, the basic of a router is just, directs our data between our networks, right? So we have our home network, right? Our home network, for example, and let's just design our home network here, right? So this is our home network, and our home network has a network, and that network has either a router, a switch, a hub, and then that's what gives us that plan back um, to the internet, right? So to that cloud. So it'll bounce back and it'll give us that connection. Again, a switch connects multiple devices. Now, if I have multiple devices, obviously, device one would connect to that switch, and then my device two would also connect to that switch, right? Um, but network card on my server. So understand how that works. We also have access points, right? And an access point can be anywhere in the home, and that'll provide our Wi-Fi signal, right? Our antenna, right? That'll be our antenna, and that'll be our antenna for Wi-Fi, right? And I'm going to make this a little bit bigger. Okay. So as you can see, this is our antenna, and that'll provide our signal to the internet, right? Our signal, and our signal band is obviously round, right? And increases as it moves up. So, right, and then we also have our modem as a device, right? And our the modem, um, in our hubs and our modem. Again, our hub is like a switch, right? But it just sends data to all the devices. So whatever devices are connected within our home. Then again, every networking also needs IP addresses, and we're going to get down into that. And it also needs network protocols. And again, every network address needs an IPv4 address, which is 32-bit, or IPv6, which is 128-bit. And again, or just a subnet where that subnet divides our network into smaller sections, right? And those are meant for security and efficiency, right? So we need that unique address called an IP address, right? And I'm going to write that word down for you here. Unique address, which is called an IP address. I think I'm going to make this a little bit bigger for you guys. So, so it needs an IP address, and that IP address is what it communicates. Um, right? What it uses to communicate, right? So we also have protocols, right? And protocols is also part of networking. And then we also have our OSI. And I think I talked about the OSI internet. And when we get to network protocols, before we get to the OSI, we talk about rules, right? So we have our rules too. So rules are also important. Rules. What are our rules? Right? Do we need rules? Right? Every device needs a rule, right? Every person needs a rule for effective communication between those two devices, right? I don't want you to go on mine. No, I don't want you to go on mine. No, I don't want to share with you. No, I don't want to share with you. I want to share with you, but I want to share with you first, right? Those are the types of rules that you would normally hear when you're having a conversation between two people or two devices, right? And that bickering goes back and forth, and that bickering is what uh, is the core protocol for the internet, and that bickering is what ensures data is delivered reliably through speech, right? But in this case, it's through bytes and bits, and these IPs ensure that the data reaches that address, right? Because each house needs an address, right? And in order for us to send those rules, or to send that data to the right house, we need the correct address, right? That's TCP/IP, and that's a communication rule that's used, right? And when we talk about that, then I'm going to bring that up here as my first point: TCP/IP. Right? Oh, TCP. transmission control protocol, and IP stands for Internet Protocol. Okay. And this is transmission. Transmission control protocol. And that is, again, it's the core pro, it's the core protocol for the internet, right? And again, in order for an IP, it needs to reach the correct address, right? You need to know where that address is, right? Every IP has an address. So in this address range, we can have a 192.168 address, right? Network with a host, right? And then that's the network and the host, where XX is host and then and 182 is the network. Um, Hosting the devices. So we also need to have that TCP in order to ensure the data. So our TCP ensures the data is delivered ready. So I want to make sure that I'm delivering this information to this host correctly and is reliable. And as this person A, right, delivers this information to this correct address, then we know that this IP, the data of the IP number, right, this data here reaches the this data is that's been the TCP data is delivered reliably, right? So whatever data is reliable, it'll make sure that that data gets there on time. And then once it hits that um, address, it'll say, "Yep, I'm here. I'm correct. I'm working, and this is the correct address." Very straightforward. We also start talking about HTTP, and these are different network protocols, right? So we have our second network protocol, and our second network protocol is HTTP dash HTTPS, and this one here is, and I'll talk about DNS and we'll talk about TFTP and SFTP. Right? So that'll be my next two topics to talk about, and I'll get those prepared for us. Rules. Right. So HTTP is Hypertext Transfer Protocol, where HTTPS is Hypertext Transfer Protocol Secure. The S stands for secure. Make sure you guys write that down. It's used by web browsers. So within our device, within our hardware, right? And you have to understand, because in network, you need to know the basics, and not only do you need to know the basics, you don't need to confuse your design or your architecture, because if used incorrectly, it'll confuse the rest of your architecture fundamentals, right? Or your architecture drawings and your architecture beliefs, right? So when we're talking about, again, back to the HTTP HTTPS, which is the secure browser, right? Is used by the web browser. Now, the web browsers are accessed where? Inside, on top of the operating system, right? So that operating system has our web browser, right? So, as a person, I'm going to access that web browser, right? So I'm going to grab some pictures here, right? And again, I'm just going to place this for um, a diagram here, so that, and this is going to be our person, and this person is going to be Bill. this person Bill or user A, right? We're just going to give them an anonymous number. And this user is using a device, right, or a laptop, and this is the device that he's using, right? So this user is accessing this laptop, logging in, and on top of that software OS, he's opening up a web browser. So a web browser could be anything. So a web browser could be web browser examples, right? Are IE, Internet Explorer, Microsoft Edge, right? These are both Microsoft products. Remember that? IE is Edge, I mean, Internet Explorer, which no longer exists, but it's amalgamated to Microsoft Edge, which is the newest and latest product. But they're both Microsoft products. Then we also have Google, right? Chrome, right? We have Chromium, Pro. Um, we also had Netscape Navigator, which was a long time ago. Netscape. That's an example of a web browser, right? So if you're way back there, right? Um, the internets are around, but locally, and this is back then, right? This is an old product. Then we had our AOL offered, a browser which was Yahoo browser, right? Yahoo, AOL, they offered their own browsers, right? And there's also MSN, right, which is another Microsoft product. And I'm going to MSN. Then we had Bing, right? Bing, Microsoft. So these are some Microsoft products, right? And then we talk about Google Chrome, right? We have our Chromium. We had Yahoo, which was another browser, no longer exists. 7, 8. And then we also have Mozilla Firefox, right? Firefox, and I think we have frontline motion or front motion. I can't remember if that's what it's called, but front motion, or frontline motion. I'll have to Google that, but it's frontline line motion Mozilla, something like that. So if I open up my browser and we look for frontline Mozilla Firefox, and yeah, see, so frontline refers to using Firefox browser to access the Frontline Education website. These are different. Front Motion, there you go. So Front Motion is the company, and that's also part of Firefox, right? For your network to thousands of clients, and a lot of companies will use that for educational purposes. It all depends on what you're using it for and what is it that it's meant for. So it's called Front Motion. Front Motion is the company, and Frontline is the Mozilla Firefox, right? So um, there are a lot of browsers, right? There's tons and tons, and these examples of browsers are synonymous to a lot of that. Front Motion, Mozilla. Okay, and these are some more browsers. Web browser. Okay. So as you could see, these HTTPSs are used by web browsers for that specific reason. Um, so the person is opening up that web page and typing in the URL HTTP, right? Or HTTPS, right? And you'll see that once you open up Microsoft Edge and you open up a new page and you're going into the URL, you're typing in HTTP, right? And that'll start off your journey or HTTPS, right? But typically we want secure because secure is the most common secure way to use this hypertext transfer protocol. Um, and then again, we also have, our next point, FTP and STP, right? And again, FTP and STP is SFTP. So FTP, right? So we can actually connect to an FTP, right? And follow that prompt to complete the connection, right? So we can actually follow that if we have that port open, right? And we can test that port to see if that's open, right? So that's how we would connect to it. And again, it's just trying to pick an open app, and that's just going to connect us to our enter. So you can see that this site is trying to pick an app, and that website wants to open up that application. So we know that our FTP is there for transferring files, but in this case, we're just opening up an app. Let's say Google Chrome, right? We'll use that for now, and we know that that's what we want. Oops, and we're gonna hit enter, and then that FTP site would open, and we were able to transfer those files. We also have our last comment here is our DNS, and our DNS is very simple. Oh, sorry, that was fourth. Number four is DNS. We're going around here. So three is FTP, four is DNS, and that is simple. That's just your domain name service. And again, and our DNS is what translates domain names like google.com externally or internal DNSs. We're not going to get into the internal external DNS, but it translates domain names into IP addresses, right? So this name will have an IP address. So for example, www.google.com will translate into, for example, here, if we take this this domain name, and we transfer that domain name to um, right? That's opens up this page, right? So in order to find out what it does is I run a NS lookup or IP config, and then I'll add that, and that right there will tell us where our server is for that specific area. So we know that our DNS name is 142.1.251.41.68. So if we put that into a web browser and give me 1 second, guys. Back. So if I put this number in our design here, right, it should bring us to the same page. Right, there you go. Just redirects us there. So that's what DNS means. It translated that IP address. We also have OSI model and different network concepts. Like I said, your OSI is a networking layer, but we're not going to get into that because I also have a video on that as well too. When we talk about the 7-layer models, we can also talk about common networking concepts. Again, we're not. We can talk about cabling too, and the connection, right, and how we can use Ethernet cables and fiber optic for speed and distance, and high speed and long distance, right? Uh, then we could use bands and frequency for wireless. And again, we can also use um, commands, which is something we're going to talk about in here, like our ping, right? Right? When we have our IP config, right? Then we have our um, tracer, right? And that'll find out with the different IP and host names, right? That'll show our route data, and that route data takes us to reach a device, right? And then we have our NS lookups and our net stats, right? So we have to be aware of how that works, and we can show the different active network connections for a net stat, right? And if we need to resolve DNS, we can check DNS resolution by using that NetS lookup, right? Let's look up. This will give us our interactive modes or just lookups. Just remember, networking connects the devices to the shared network, and just the takeaways that we want from here, and our IP addresses and routers and switches and protocols are sort of like the building block, right? They're a building block. Um, these devices are building blocks for our, you know, home office or wide connection. And then we have to understand the OSI layers, right? But that's not going to be part of our network on what we're talking about here. But, we have to understand that as well, because that'll help us troubleshoot networking issues. And please watch my other video for that. I have another video. And then lastly, the security, firewalls, encryption, very essential, right? So understand how that works. I'm going to take this picture. And I'm going to post it diligently in my chat, right? So there's my person accessing the web browser, and then that web browser gives us that access to that internet, right? So that's what the person is. And this person is using a laptop, and this is what the laptop is, right? On top of the software. So the OS is physically this area here, right? That's our laptop area. And then on top of that screen is where we have our hypervisor 2, our hypervisor 2 software, right? So we opened up the software. We're accessing our virtual machines. All right, so let's copy that. Let's put that in the notes. Good reads. Oops. Very straightforward. Okay, so we talked about the networking. We talked about the basics of networking. We kind of get the concepts here. We got the takeaways. We drew out our design. We mapped out our our infrastructure. Um, we've drawn and mapped out different areas of our specific scenario environments. And my main topic here is to talk about um, network address translation and how it's used, right? How it's used, how you see me using it a lot, right? So you will see me using this very much, and there right? So that network address translation is what translates my networking, right, in my environment, and yours as well too. So if you are, and this is very, very important, right? Because a lot of people get that mistake when they're talking about this stuff, and it's not easy to know, you know what that is, but like, what is it? Why are we using it? And we did talk about this as being a protocol, and behind it, you're not really exposed to the network, right? And again, it gets the IP from that DHCP that's sitting inside our VMware workstation. It grabs the internet from my physical network, as shown in the diagram below, right? It grabs it from my physical network, and it gives you that internet connection, right? So in that protocol, again, it's used to share the host IP addresses, so we can have a public IP to a private IP translation, right? So we can create different translations that way. You don't need to purchase any public IPs for a machine, so which is good. We just have we just have our ISP that's giving us that that gateway or subnet, right? That internet address, and different ranges that it'll allow us to provide, right? And again, in that it's not routable. These public IPs or PIPs can give internet connection with the help of the NAT protocol to thousands and thousands and thousands of private IPs, right? Based VMs. So it does have something to do with it, right? And you'll see when we're creating a machine, it'll give you the different types of, right? And in this one, I want to touch base on the differences between the custom VNet, which is similar to VLAN, right? And the 19 different networks. And you'll see 4 virtual machines that can communicate. For examtle, with VMNet 4, those virtual machines can communicate with the 13 virtual machines. So, and then you also see the separate independent networks and the machines inside that can't communicate with each other, but they can't communicate outside of this network with any other network, right? So very important. Just remember, VMNet 8 is similar to NAT, but what's the difference between, just why not give it just the NAT protocol versus why giving it the VMNet? And that is a topic that, you know, kind of confuses a lot of people, because the difference of NAT is the difference, right? There are differences. And in VMware Workstation Pro, we can attach a VM's network adapter to different networking modes, right? So two you're asking the two you're asking about are, you have your custom, which is what we just discussed about, which is our VMnet 8. And if we look at our adapters, we have our VMnet 8. And then if we were to add a specific machine or a specific another network adapter, we can also give it the NAT protocol, right? And this is important. And I'll tell you why. It's not just an abbreviation, right? It's something that means a lot. So if you decide to add another network card, right? The network adapter, as you see here, right? You select the network type, right? And that's our network adapter. You want to add it, just click finish. So select, highlight in blue, and then click finish. And you'll see that right away that this network adapter 3 is connected to NAT, and that's used to share the host IP address, right? So why do I have one that's a VMNet 8 and why do I have one that's a NAT? And what are the differences, right? And here's why. Um, Custom VMNet 8 with NAT lets us create our custom virtual network. So we have from 0 to 18. And as you can see, when we go back to our diagram here, we have our custom, sorry, 0 to 19, my apologies. And you'll notice that some of them are written out and some of them are spelled out, right? So we have 19. All right, 0 to 19. Apologies there. So if you configure the VMnet 8 and set it to use NAT, you now have a dedicated private subnet, right? It could be anything. It could be dedicated to this VLAN, right? Or network. Doesn't matter what it is. right? But we know that 192 and 168 is the network portion, and xx.xx is the host. So it doesn't matter what subnet, right? 192.168, right? 1.0, 2.0, 3.0, et cetera, et cetera, et cetera, at the slash cider 24, that only VMs connected to VMNet 8 use. And that's what the private subnet is. And if we configure that, we set it to use NAT, we now have that private subnet, right? We also have a virtual NAT device, right? And a DHCP server running inside that VMware that handles IP assignments and outbound traffic. And I'll get to the actual physical component here, and so that you guys understand what I mean, right? In terms of the data that it creates, right? The config files and the leases that it creates, and all the files within this file when we download it, right? So when we're downloading this program, we're downloading data to it, and not just data, we're downloading specific files and folders, right? And you could see a host of different files and folders here, and copy, and we know that this is right. So we know that this is where the location is, right? So this NAT device is DHCP server, right? So if we're using our physical network, and our physical network or router is giving us a DHCP server or static or network, whatever the case may be, that's what's giving us the internet from here, from our device to our network card or NIC card, right? So our NIC card, insert text, and I'm gonna make sure that I write that down. So this is our NIC, physical NIC, right? And I think they denote it by Ethernet 0 or Ethernet 1, whatever the case may be, right? Right, and the more physical NICs you have, the number increases, right? So if your first NIC, physical NIC is 0, your next Ethernet NIC is 1, and et cetera, et cetera, et cetera, right? So as you saw there, you know, more control, right? Like those that's where our DHCP server lives, right? And that's where our internet's coming from our gateway, and that's what's giving us the that's what's giving us the control, right? For that the where our VMs are going to get those IP addresses from, right? And the more control, where we can kind of tweak subnet ranges. We can kind of, and this is what the custom VMnet is, right? We can tweak the subnet ranges, the DHCP and the port forwarding, et cetera, in this scenario. And I talked to you guys about all those different concepts and networking concepts in other videos, like private and public IPs, NAT, DHCP, firewalls, and LAN versus WAN, right? Small versus large. So another thing that comes to mind when we talk about custom VMnet and 08 with NAT is it is useful when you want isolation between multiple networks. So for example, um, you have different NAT networks, right? And one group of the VMs on VMnet 8 NAT, where another group is on VM 9 NAT. You can call that whatever you want, right? And you can give those, uh, you know, that specific uh, topic where these two machines can connect with each other, right? So in this case, this machine, if it's on VMF, whatever VMnet it is. So for example, right now I only have NAT, right, which still gives me internet, but we also want to give ourselves internet. If it was static, it wouldn't, but because it's dynamic, it's going to give us internet. So in this instance, I'm going to add another adapter. I'm going to show you the difference here. And in this instance, we are going to give it 8, right? So we know that these communicate with each other, and these two machines will communicate with each other, right? and we can ping each other and we can share files and data within that realm, right? So these two machines will communicate with each other. So as we're moving forward, um, when we talk about just the basic network adapter, as you could see in some of my in the first machine where we had our second machine where we just added the custom. One, we just select NAT for VMNet for VMs, virtual machine network adapters, without explicitly pointing to it, which is sort of what we're doing. VMware maps it to the default NAT network, and that's, as you can see, when you're building a machine, it'll automatically do that, right? So when we're building a machine, building a virtual machine, just a quick virtual machine, for example, and I will install the operating system later, and I will give it a Windows, let's say Windows 2019, right? And I will click next, right? Just something quick, next, next, right? And you'll see right away that network adapter is given by default, right? And we can customize that however we want, right? And that's the default. So once you finish it, it'll create this virtual machine bare metal with no operating system on it. But just to let you know that it automatically gives you that right away. So just make sure that you're aware of that. Not going to finish that. Um, Another thing with network adapter NAT, default NAT, is you don't get to choose or customize. It uses a predefined NAT network and subnet that VMware sets up. And there are files that'll show you that. It's simpler but less flexible. I've used this so many times. There's so many different scenarios you can play with. But when it comes time to what are the main differences, right? Here's a chart that I kind of gave you guys where, we can give those main differences between the two and why you would choose that and why not. You're leaning towards a custom VMnet, right? And that's what everybody is leaning towards a lot of the times. So when we're looking for subnet control, yeah, our custom VNet allows us to pick IP ranges, which is what we want, right? When we're creating our class A, B, and C static, right? Whereas our NATs, they don't allow us to change it because it'll provide us the DHCP from your network. Um, Another difference and feature is isolation. So we can isolate multiple networks in groups, right? Or VLANs, right? Where those VLANs will communicate with each other. Those devices within those VLANs can communicate with each other, or VLAN networks. Whereas in a default adapter, all NAT VMs share one network, and that's the only network that it shares, right? And I'm going to DHCP control. We can configure DHCP dynamically here. We can use and with our VMNets, which is something that we can do when we're setting up dynamic and static IPs. And I have multiple videos on me doing that. Um, when setting up DHCP's roles and features in our servers. And again, another thing for default NAT adapters, just the NAT adapters, it uses a default DHCP control, right? And then when we talk about port forwarding, we have full control of port forwarding, right? And those rules that we talked about in our picture here, right? We have full control of that in a VMnet environment. Very important. And we have limited across all, obviously we have limited control, right? Once it's shared across all NAT VMs, and that's within our default NAT adapter only, right? So you'll see a huge difference here between these two network adapters, and I want to give you guys a picture of what you're gonna see here. So this is option one, and this is option two, right? So custom, and then that. So understand how that works, right? Okay. And then our last is our use case and the differences between our use case scenarios, right? And again, use case scenarios, you'll see me use this a lot in lab setups, in multiple environments and even just test networks. So you'll see me use that a lot in my different test networks. And you also see me use the NAT adapter, and you'll say, "Hey, why do you use the NAT adapter only? Why not just use the VM?" And my use case is just, for quick and simple internet access to VM. I need to download Google Chrome, or I need to download something in my machine. It gives me internet, right? So if I were to connect to one of my machines here, um, you'll notice the adapter. I'll come back to that, but you'll notice a difference, right? Uh, that's one of the main differences. So let me break it down for you, and in terms of logic, and it's a logical piece of software, not physical, because that's how VMware NAT works, right? And we look at the logic behind the VMware NAT and the custom VM NAT, and also where the VMware stores its configuration files, right? When you install that. So when we install that, we have a network virtual layer, and when we talk about that, um, that step, the VMware Workstation make this bigger, installs a set of virtual network devices on your host. So that'll install all the files. So you'll see all the files being installed, right? And you'll note it's a little bit bigger. So these are the files that it installs, and folders, right? And on our host machines, right? So even on our host machines, it'll install them, and we can see them in Windows network connections as VM where adapter network connections, and you'll see that when I install it here. I'll open this up. Let me log in. Explain to you in a second here. This is a machine or your laptop, right? So I'll log into my server, and you'll note here at the bottom, you'll see the internet access, right? And these are the different connections, right? So if we were to go to, and as you can see, right? Oh, sorry. Um, go to the settings here, right? So we have our custom networks, right? And identified, right? As we don't have that machine yet that's connected to that VMnet, but we are connected to our second, right? And when we go to our adapters, right? When we go to our adapters, right? We capture our adapters here, right? And our two 0 and 1, right? So these are the two different ones, and you'll see different notes of that, and you also see something about VMnet, right? A virtual adapter here, so you'll know that what that means, right? Um, that's it. Like it's in Linux, it's the same thing. It's pretty much self-explanatory, right? When we're talking about these Windows network connections, right? So we're going here and we're going to network connections. We're opening up the network connections, and we get to see the default setups, right? So again, in this instance, as VMware Network Adapter VMnet 1 or Network Adapter VMnet 8, and etc. So that's what you're gonna see, right? You're gonna see that a lot, right? And that's how it installs the virtual network devices on your hosts, right? So our hosts. So we'll also see inside the virtual network layer. Logically, we'll see the VMnet, each VMnet It's like a virtual switch, and we'll see those layers, right? Um, that's gonna act as our virtual switch. Again, our hypervisors, we can create our own virtual switches and our own networking devices, like VCSA devices, um, more later on. Copy, and here I want to put this here just so that show you another section or area. There you go. So as you can see, there's also in our vSphere, in my vSphere client, I also have networks that I can add here, and I can add my different devices here, and even in Hyper-V too, in Hyper-V as well too. You can also do that as well too, right? So here, if I were to go to open network sharing connections, I would now be able to see my different connections within there, right? So I'm going to give the properties here, and then that's where I can get my IPv4 IPv4 and IPv6, right? When we talked about um, IP addresses. So moving forward, default setup, right? The logic, we look at the default setup, right? VM.1 is host only. VM.8 is what NAT is. And we can add more as custom networks between 2 and 9. And we can allocate the separation of administration that way and management. Then we also have our NAT operation and what network address translation operation is. And when a VM is connected to VM.8 NAT, that VM gets the IPs from a VMware managed DHCP service. And you'll see like a weird service. Sometimes you'll get like a different IP. Um, I don't know if I open up command prompt, I'll get a different IP if I have that network signed, right? You'll see like a weird IP, right? A dot 44, 137 or dot 49, which is the IP pub. But anyway, you kind of get the gist of things. You get a different network, right? Based on your on what it wants to give you logically, right? So it'll make up its own IP network, right? And in this instance, right, we know that our network is that, or our VLAN is that, and our host is whatever it set it to be, right? So in this case, it was 137. But again, we can release and renew these IPs easily and assign a different numbers as we need. All right, and then renew those IPs. And there you have it. Right? So right now, if I were to release and renew, and this is just basics, right? And a lot of people lack basic fundamental skills sometimes and get stuck in an interview when it's asked. And sometimes, yeah, it's not how you say it, but it's knowing how to talk about it, right? And how to make it as easy as possible. There's a lot to talk about in specific interviews, right? And discussions and presentations. But when you're teaching people, there's only one way. There's multiple ways of doing things, but there's only one real way to learn um, the concepts, the science, right? And um, you know, knowing when and how to use it is also important, right? Did it finish? All right, so let's see. If I do the IP config now, right? So automatically gives us that number there, and we know that that's what the number is. So let's kind of get into the back end of it and the science of it, because I'm curious to know why it designs and it gives us that number, right? And which is kind of cool, right? So VMware runs a NAT service, and on the host that translate the VM's private IPs, and that NAT service that's it's running on a NAT service on that host that's translates the VM's private IP into the host IP for outbound internet access, right? So from the outside, it looks like traffic is coming from the host machine. And that's how we know the operation of that is working. And inbound connections need port forwarding if you want them to reach a VM. And when we talk about custom NAT, right, with example VMNet 8 is what we want to talk about. Same concept, but now you define the subnet, right? Now you define the DHCP range. Now you define the network. And what do you mean? So right now, what we'll do is we'll define an IP for NAT. And if I am not mistaken, do I have VMNet 8 on this one? Let me double check. So I'll define it here. So this is defining our network, our internet, right? So this is what's going to give our network. So even if we open up Internet Explorer, it should work. It's later. So if I open up that, and I may have to shut off IENAT security, but let's see what happens. Yes, over secure connection. And I will allow that, all right? Because I need to know what that is. And I will add that because I know it's trusted. And there we go. I don't know what gstatic is. So I'm going to close that. So just to kind of give you an example, right? So again, I can search anything. I can search weather, right? So what's the weather? It's one.com. Just going to remove that. I don't know what that is. Weather. Close. And close. Weather, right? So there you go. I have the weather, the current weather. I have time. Right? So it does whatever I need it to do, right? So and when we talk about back, we can define the subnet, we can define the DHCP range, we can find the NAT rules, and this is how we can do that here. And we can define all that here in the properties. So this is where we can define all that. In this case, I'm going to unclick that properties and define my IP address based on whatever class I want to give it, right? This also, again, lets you separate labs, right? Which is what we've been doing here and what I've been doing for the longest time, and gives VMs different isolated environments, right? So, you know, that's also important to know. Next topic is where the files are located, and this is a question that everybody asks, and you know, I show you guys here that these two files are where we would edit these specific ranges, right? And edit the different, and this is important, right? So, um, so this is where we're going to, you know, edit our configuration file, right? For running VMware on Windows. And this VMware installation procedure is added each time you add or delete a host-only network adapter. So this will kind of change as we supply domain names to make pump, like Red Hat happy, or just a set domain service to make clients happy, like DH client as configured in SUSE, Turbo Linux. This is where you would kind of go in and make those changes here and make changes to those virtual Ethernet signets, right? And again, we can change this to whatever we want, right? And again, I can make changes to my range here, right? My subnet, I can change my subnet at any time. So in this case, I'm going to change it to, let's say 60, right? And I'm going to make the changes to my range here because I know I changed the range, right? And logically, I'm able to now make those changes, right? So anything from the 44 would change to 60 in this instance, right? Right. Let's see. Right? It doesn't matter what we choose, right? But we can change this to anything we want. We can have different fixed addresses that we want here, right? And that's going to be our fixed address. And the more VMNet hosts we add, the more we can edit the VMNet hosts here. And this is important because not a lot of people understand that this can be done. And as you can see, I'm able to do that in a way where, I give myself the freedom to do whatever I want on this instance, right? And all I need to do now is save it, right? Well, this has to be done in PowerShell or command prompt, but right. And then that way it'll save, right? So we'll save that file, right? In administrator mode. And then obviously make those changes that we made there, right? So right, there we go. And then I'll save it. Right? So I've now saved that file. Just remember, before making any changes, make a copy of the file, test the file out, right? First, if you're scared, right? So obviously make a file, copy it, and then paste it, right? So make that copy and then learn how to edit with that and then run that specific file there. Once you tested it, you can delete it, right? And make that change there, right? Back that up before you do anything. So again, we open that and that's our DHCP config. So we've now changed that. So let's see what happens when we change it. Refresh. And I hope that that's what gives it. Let's see, when I run the IP config, should give me the should take a little bit of time, but let's check. Remove. This should automatically bring up the new network from 44 to 60 if my math is correct. Let's check. Now I'll run the register flush DNS register DNS command, and I'll see if that works. But I don't need to because I'm just trying to release the IP and renew it so that it reads the new IP. It's just taking too long. Let's see what happens now. It's taking a lot of time. It's sad. Let's disable it. Enable it. See what happens now. And once so if we now try to ping this machine, it should now work. Well, let's go ahead and release. Let's try to restart this machine. Restart the machine. Restart. Continue. All right, so that's not how it works. It looks fine. I think yeah, so it should be okay now. let's see what happens. But anyways, you guys kind of get the handle of how that works. So I'm going to hit the Control Delete. I'm going to sign in again, and I'm going to test my connection, and hopefully it works. Well, let's see if it gives it internet first. Right? And we'll see if it gives it internet. MSN. Looks like it's connected. I have internet access. I'll change that password later. Not important right now. Let's try IP config /all. It's taking some time. All right, we'll look into that, but understand that that's where we can change that IPv4. I don't think I saved it. I think that's why I didn't save it. But yeah, this is where I change it. I modify the files. This PC. Yeah. That's that. And so run, see if the host has this file too as well. We'll look at the host file as well too. And I should have that file there. Yeah, there. No, that doesn't have it. So it's just a mismachine here. So yeah. So yeah, I didn't save the file. That's okay. But you guys kind of understand, right? And then we also have this file here, right? And this is where we go to program data. That's okay. I didn't save it. It is what it is. We also created the NAT config and the port forwarding and stuff. Now, this is where the NAT stuff is. If you had your NAT configuration, right? So we would open up the NAT conf file, and we would open up that with NAT config, and this is where we would give our NAT gateway address, right? We can specify the device name, number, allow sources, TCP connections, right? All the stuff here will be in this file. So any changes that you make here. You would make here, and you would save that file. So in this instance, um, you know, you would have the gateway address here. That's our gateway address, but you would have to change your gateway address, obviously. See if that works. Save. Oh, okay. Yeah. Now let's open that up and let's change that. Let's save it. See what happens now. And let's go ahead and refresh. And let's go to let's go back to our machine here. Let's see what happens now. Let's go to the status, details. Okay, so let's release and remove. Let's try now. See if that helps. But not, I'll just focus on. I'll grab change it up. I know the gateway was changed anyway, so the default gateway was not changed, so it didn't pick it up yet. So let's go ahead and release it. Flush DNS, flush DNS. Yes. register DNS, register. Enter. Okay. And then we'll give it the IP config. No, not yet. Let's release it. Release. I'll have to reset the computer. That's fine. No. VM. I'll disable it. I'll have to disable it. I think I might have to disable it. But you might have to disable this first. If it doesn't pick it up, it just takes time. I'll deal with that. Or it just the machine itself may have the file already created with that IP address in it, and it doesn't want to take it yet. So might have to just create a new machine, right? So we can just create a new virtual machine and see what happens for testing purposes, right? So we can create that server. Doesn't matter where I put it. And so just test. Okay, next. Next. Right, so there's the NAT already created, and then that'll, once it's created, it'll create the files with that. So let's take a look. Try that. Let's put the CD DVD. Hit OK. And this will have, and I will give it do, 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 do. And this will have a Windows 11 machine. See, a Windows 10 machine. Go to Windows 10. And we'll hit OK. There you go. Let's take a look at that. Give it more 4 GB just for now. And we'll have one processor, 2 cores for a single machine. It's not going to be a it's a Windows 10 machine, right? So we'll rename it the Windows 10. I'll rename that after. But it's a Windows 10 machine. We know that. And this is going to have one processor, 2 cores. Okay. Power on the machine. So that's the specific. So inside each VM folder, you'll have a VMX file, and that tells us, and we know this already because when we go to like that file itself. So, for example, so this is where the global networking config files are, right? But each VM also has one, right? So when we're going to the virtual machine, right? and we're opening up our test machine, right? So this is our test machine that's created today. This will also have it. So we're opening it up. This will also give us our, let's open this up with Notepad++. Right? So this will give us our network information here. Right? All right, that's it, guys. It's pretty straightforward. It's pretty simple. This is where it is, right? This is where I'll have all the information that we're going to need. So it won't really matter much. But again, know the areas, know where to troubleshoot them, know where to go in certain scenarios. Oops, right? It's always good to know where those areas are, know how to manage them, um, know how to make changes to them, get those done, right? Then we have again, and then we go down, and then again that VMX file is where it tells us where that bridged adapter is not, et cetera, right? You'll see it here. We can do a control F and VM net. It'll show us if it doesn't have it. If not, then it'll probably show something else, right? So okay, it'll highlight that. So that's our Ethernet connection. So it'll tell us what that is. Okay. Um, so on Linux, when we're opening up, I don't do this now, but in Linux, again, you're going to SSH into these machines. And once you, with SSH, right, in SSH, right, you're going to enable SSH in this machine. And I think, yeah, it's right there, that option there. Once we turn that on, it'll allow us to enable and disable there. Okay. And this is where the config files will be here. So this is where we're going to find our network adapters here. So it's very simple. We also have our NAT config file. I'm not sure if I showed you that NAT config file. Let's see. We have the NAT config file here. And this one here, if I open it, right, we can open the file, and inside I might see the incoming um, TCP. So incoming TCP, where is that? Right. So I'll have, I can add the TCP and UDP for 8080, right? I can make that change if I want to, and I can forward the hosts to 8080, right? If I want to, right? So in this instance, I do not have anything set up here, so I can take this file here and then forward TCP incoming traffic to this machine. And this is where you can control port forwarding rules, right? Within here, and I can set those up in this file here and make those changes here whenever I need, right? So I can make those changes and then set that up. So in here, I would add the 8080 or 888. So in this case, it shows 888 as something here, but again, you can set these, you can use these with care, and then anyone can enter into your virtual machine through these, right? If they want to. So that's where you would uh, do that. And so I'm going to take a picture here. It's here. Post this in my notes. And again, share your results. Share your results. So we can see the logic, right? We can see that the logic um, is there. And when VMware installs virtual switches, we have our VMNet adapters, right? And when we look at our NAT services, right, and plus we can manage those networks too. And then I think this is available here in our task manager, right? So within our task manager, these services, right, these are the two services that we would look at. And, you know, these two services are important, right? If they're not there, then your service is not running, right? That's how we can test that. So just like here's a picture. So if this service and this service um, together are available, then we know that it manages the networking, right? And this is where the logic is. We also have our config files we talked about, and the two different config files that are used to store subnets, right? And so we open those files here, right? Right? This is where we would store um, the subnet and manage and ranges and port rules. And we can also isolate extra subnets using the same network. So we can add custom NAT and make this as special as possible, right? So modifying these is something that we can definitely do within their environment and something that your network you guys can do if you need to, right? And you can modify those networks and make those public and private as much as you want. Um, Again, we can walk through different examples, right? And again, these are taken from our program data, right? From Windows and from Linux, it's taken from there. But we have to understand that when we're formatting these specific rules, um, we can, you know, change the different NAT networks that we want, right? If this was your NAT network or host, whatever you want to call it, right? We can format these host ports and make those equal to your VM IPs, right? And then your port, right? So that will have your port, your VM's IP, and then your host port, right? So we can do that. And we can, add to our incoming traffic where our forwarding UDP, our user data protocol, is used for more for gaming and custom services. Right? You can modify these to however you want, right? So just be aware that you're doing it properly and make sure that you have that right person. Then once this is done, this will create a log, which is what you want to have done for sure. I normally would, change that to a temp file or wherever you want to put that in. That'll have our log of when that is done, right? So typically the M.8 would be, again, this would be your 8 adapter, right? And that's what VMnet 8 is. So you'll have your network, right? So this will be your network or VLAN 8, sorry. And you'll have your different, which equals X, 8 is X. And then we know that X is equal to 8 in this instance, right? So you'll have the 8, you have the 8, right? So that's what you want to do, right? And you'll give it your different host numbers, right? So in this instance, we assign port 8080 and 2222. And typically port 2222 is port 8080 is okay. 80 and 2222, right? So port 80 is obviously web traffic, whereas your port 22 is your non-standard port. So for secure SSH, right? So this will be for SSH, and I'll write that down too. do SSH, right? And then in my code, I'll write this as web traffic. Pretty straightforward, right? Just remember the incoming TCP and incoming UDP is where you do port forwarding. So this is where we're going to be doing our port forwarding in this section of that config file. We added a log file here, and that log, I think it's there. If we have it or not, I'm not sure. If it would be in here, and this will have a log of where all the information, anything that we would do here would be not in this log folder, but again, I don't know what this is, but this is simple installer cache file. So this is just installer cache file logs, separate from what we're doing here. So you have a log.txt, and this is where I would put the nat log for that, and I'll have that nat log there. Test it, share your results. Then we also have our config DHCP, same concept. We have our configuration for VMnet 8, right? So our network, right? Our different ranges, right? So here's our different ranges. Option broadcast range, name servers, local domain names, default lease times. This is all, and then example of static reservation if we are using based on a MAC, right? Just remember that the subnet block defines the network there. So in this instance, it's part of the subnet 8.0, right, which is your VMnet 8 range, and DHCP pool range is equal to the DHCP pool for the VMs, which is the automatic assignments. And then you'll see host name, right, allows the static reservation for the VM MAC address, and then DNS is usually the MAC gateway, right? So whatever the gateway is for that network, right? So whatever the network gateway is, so it would be 844, whatever you want, whatever you set it up to. So that's in the vmnet.dhcp.conf file, right? So let's see if we can open that. Let's open that. Let's open that. Okay. Add DHCP configuration if there was one or not one, but this is where you would add that here. Just to make sure that you add the end here too. We have to add the end. But this is where it is. Okay. You can test that and take a look at that too if you want. Okay. Snapshot of that. Snipping. And I will put it in our notes. It's a good read, research. So yeah, that's that. Next is summary. Again, it gives IPs to VMs, right? It'll give our network or VLAN, right? For DHCP, whatever we set it up to, right? In this instance, it would be 44.8, right? And we can make changes to those. I didn't save it, so I wasn't able to show you guys. And then we also show how to set up port forwarding for SSH, right? We know that SSH is 2222, and we can identify our VM and our network here. And these are some steps, I think 5 or 6 steps that I have here to show you how to do that. If you're interested in learning, right, we'd open that comp file if I have it, that comp file, which is right here, and then which is what we did, and in the administrator, right, and then locate the incoming TCP, which is right here, and there's nothing in here that's open right now for that, which doesn't allow us to use that concept. So this is where we would make the networking changes and locate the incoming TCP section, right? Which is what we did. And then in step 3, we add a new line in, and we can add this as a new line. Right? And we can also, for multiple ports, just add new lines, right? So number 4, we can restart the NAT service. Once that's done, this is what we're supposed to do. We're supposed to restart it, right? In the services. And then this will reload the conf so the new port forward works. Instead, I think we went through instead we used command prompt, right? So note that this is the way to go. So we would run the services.msc, right? And then we're looking for that specific NAT service, and we know that that NAT service is called netnaf.conf. Okay, there's the service, right? And then that service we can restart. Let's see what happens. Let's open up our machine, start our machine. Try again. The settings, right click, status, details, did not change yet. So let's disable, let's enable. Let's try now. Right click, command prompt. Oops, that's not IP config. Did not change it yet. So let's go here and run it from this area. See if that works. If it doesn't, then I'll just test it all another day. I'll create a video once it's done. Those IPs. Okay. All right, so let's go ahead and boot normally. Let's try to still didn't want to change it. Okay. Let's figure out why. Another day. Okay, so know where to go. Know that this is where the ports are. This is where you're going to be. And if you wanted to enable the port, just remove that. That'll enable the port, but in this case, we're not going to do that. And save the file. Right? Just make sure you save all. And if you need to run it, why not run it? Right? And stop it, stop recording, run recording, right? Yeah. All right, so this will reload the conf so that the new port forwarding works. Test it, let me know, and then we'll test the connection if we did use 22. So we can use that and test it, and it'll tell us whether or not the SSH was connected to the host port, and then we should successfully reach the VM via NAT. Right? That'll kind of work. Again, we can set up static IP reservations if we need to, and then restart the DHCP service after editing. That's an optional static IP reservation, you know, which is something we can do and, you know, get that done. It's an option. I'm just going to click next, install now. And let's open up the command prompt with admin. paste, and remove the logo here. And click enter. Oh, and username. Oh, username. So SSH does not work. So let's see if we can get run on this one here. So we can get PowerShell as a PowerShell as admin. Or we could have just did this. We could have did PowerShell shell.exe and then see what happens. Okay. So they're saying that the term SSH is not recognized as the name of a commandlet. So let's go ahead and run it in PowerShell. Check the spelling of the name SSH. SSH is not running. Why? Why is it not working for me? On your host machine. Oh, host machine. Okay. And the VM user. So what was my VM user? So let's go ahead and host machine. Let's see who the user is. Right. Right. So this is not recognized term until like, okay, let's see what happens here. So it says check the spelling of the name or if the path was included. Verify the path is correct. So we have that, that, and that. And this would automatically work because obviously it's not included in the configuration file, right? So this would automatically work based on the step 4, right? Which is modifying this line, adding this line of code on the port on your host machine. So this would have to be right. So we would have this like this, right? This has to be added in. So in order for this to be added in, do that, save it, right? So step 2, add this line of code in here. So we would add it to the um, incoming TCP, right? So, and then we would add this to the incoming TCP. So we would have to add it to the incoming TCP for the NATConf, incoming TCP, incoming TCP. So we would add it here, right? So this would be this, right? So let's open up this. What happens? See what happens. Okay. So if I were to save this, then this would work automatically. I know this would work right away, right? So it would be this and would run here automatically, right? So I understand that that's how that works. Okay, so follow the instructions, then go ahead and do that and let me know. I'm not going to make any changes because I don't need to right now, but I want you to try this out on your end as an assignment and let me know. I want to thank you guys for your time and patience, and I'll talk to you guys later. Have a good one.